Hello everyone, welcome to my channel. I am Balaji Chandrasekharan. Today I will be discussing the 12 factor app methodology. The 12 factor app methodology is a set of principles designed to guide the development of modern software as a service, that is SaaS applications. These principles were outlined by engineers at Heroku and have become a widely accepted standards for building scalable, maintainable and resilient web applications. The 12 factors to build a scalable, maintainable, and resilient web applications are Codebase, dependencies, config, backing services, build, release, run, processes, port binding, concurrency, disposability, dev prod parity, logs, and admin processes. Let me dive deep to illustrate each of these 12 factors along with examples. There should be a single code base tracked in version control like Git, SVN, and code commit, but can be deployed to multiple environments. It promotes consistency across deployments. The code base principle states that an application cannot be archived and versioned in multiple source code repositories and vice versa. This means that a source code repository can only contain one application at a time. Each commit to this single repository can produce artifacts that will be deployed to one or more application execution environments like test, acceptance, or production. This single repository can also contain resources like build or release scripts like YAML files and resource provisioning scripts like Terraform files. If an anomaly or bug occurs, rolling back the commit will restore the application to a stable state. Multiple apps sharing the same code is a violation of 12 factor. If multiple applications share the same code base, the solution is to factor this shared code into libraries, which can be included as external dependencies. Declare and isolate the dependencies explicitly. Use the dependency management tool to ensure consistent dependencies across different environments. Declare all dependencies completely and exactly via a dependency declaration manifest. Furthermore, it uses a dependency isolation tool during execution to ensure that no implicit dependencies leak in from the surrounding system. The full and explicit dependency specification is applied uniformly to both production and development. One benefit of explicit dependency declaration is that it simplifies the setup for developers new to the application. The new developer can check out the application's code base onto their development machine, requiring only the language runtime and dependency manager installed as prerequisites. They will be able to set up everything needed to run the application's code with a deterministic build command. If you are using a Python application, you might have a requirement.txt file listing all Python dependencies and their versions. For Node.js applications, you would typically have a package.json file listing all the dependencies. The config factor states to store the application configuration in the environment. It states to separate the configuration from the application code and store it as environment variables. For example, instead of hardcoding database credentials in your application code, you will read them from environment variables. For instance, a vault such as Azure Key Vault or the secret keys from the AWS Secret Manager can protect the sensitive configuration settings and serve them to client applications through URLs. This approach also allows you to change the values of variables based on the target environment like development, test, staging, or production. The runtime environment must inject configuration information as environment variables in 12-factor applications for these reasons. This keeps it strictly separate from the code. Treat the backing services like databases, caches, queues as attached resources. It means that the application should be able to swap out one service for another without affecting the operations and with minimal changes to the code. For example, if your application uses a Postgre database, you should be able to switch to MySQL or any other compatible database service without modifying your application code significantly. This is achieved by using a common interface like SQL, using the object relational mapping ORM, and relying on environment variables for connection details. Strictly separate the build, release, and run stages. Ensure that the same artifact is promoted through different environments. The 12-factor app divides the deployment into three steps. Build is the generation of artifacts from the source code. In this step, the code is extracted from the source and checked with the compiler to check the syntax. The binaries such as exe, dll, jar are then created and the code is tested using the unit tests and analyzed for quality control. The output artifacts are stored in the storage spaces like Docker or any containers or in any external repository like Maven with proper versioning that the release service can access. Release will happen once the artifacts have been generated. They are deployed to the target environments by applying the necessary configurations at the release stage. The release must be immutable, versioned, and unchangeable. Run steps include the following tasks: the environment provisioning, such as running Terraform scripts or database migration scripts, releasing binaries, dependencies, etc., running the application, and starting one or more processes. For example, you might use a CI/CD pipeline that automatically builds your application, runs tests, and deploys it to different environments based on the triggers, like a new commit to the master branch. CI/CD approach is strongly recommended when using this principle. This artifact produced by the build process is the same one that gets released to production. Execute the application as one or more stateless processes. Applications should be designed to be stateless and share nothing. A stateless architecture facilitates horizontal scaling by adding multiple run processes to handle a huge workload. It is better to use resources like a storage space or cache server that can be considered and treated as external resources when you need to save the state or run results for a process. For example, a web application serving HTTP requests should be designed to handle each request independently without relying on server-side state. This enables you to scale out by adding more instances of the application behind a load balancer. The number of scaling issues all systems face is the management and storage of state. This factor ensures that each system should manage its storage layer, and if other systems need to access that data, it should do so through a well-documented API. The port binding factor export services via port binding. Applications should be self-contained and export services via a network port. The port binding principle allows an application to be self-sufficient and identifiable on the network by giving it a port number. For example, a web server listens on port 80 for HTTP requests or port 443 for HTTPS requests. The application should be configured to bind to these ports to serve traffic. The internal port will be linked to the external port, usually assigned by the cloud provider or by an on-prem server, thus avoiding port collision problems with other services. The concurrency factor enables you to scale out the applications via the process model. Applications should be able to scale horizontally by adding more instances of the application. When a web application reaches its capacity limits, the solution used to be to increase the size and power of the server running it. So, if you only need to support a high number of requests per minute for a given period, making your application more elastic and scalable may be a reasonable solution. There are two approaches for scaling your applications or infrastructures: scale out and scale up. Scale out is one of the modern approaches for 12 factor applications. You can manage the number of cloud instances to grow your application and make it scalable and elastic. A single large process can be turned into a series of smaller processes by scaling out an application. You can then spread your native cloud application load across these small processes. Scale up is not the recommended first choice for scaling the 12 factor applications. However, it is an option for scaling virtual machines. For example, scale up allows you to increase the RAM, the number of processors, disk space, etc. Remember that scaling up to increase the machine power will inevitably involve additional costs, so you need to select your machine attributes based on your requirements. For example, if you have a web application, you might deploy multiple instances of it behind a load balancer. Each instance can handle incoming requests independently, allowing you to scale horizontally as traffic increases. The disposability factor enables you to maximize robustness with fast startup and graceful shutdown. Applications should start up quickly and shut down gracefully without losing data or causing disruption. An application and its infrastructure have an ephemeral life cycle in a cloud instance. It is worth noting that a 12-factor application is disposable, meaning it can be started or stopped at any time. For instance, an application that cannot rapidly start up or shut down cannot be scaled out, deployed, put into production, or recovered efficiently. Many applications are written so that they run several lengthy processes on startup. For example, fetching the data to fill a cache or setting up other runtime dependencies. Handling this type of activity separately is critical when implementing a cloud native architecture. For example, you might outsource the cache to a backing service so your application can start up and shut down quickly without performing front-loaded operations. Also, your application should handle allowing it to shut down cleanly without interrupting any ongoing transactions or process. Additionally, it should start up quickly to minimize downtime during deployments or restart. The Dev and Prod parity factor recommends keeping our environments like development, test, staging, and production as similar as possible. By doing that, it will minimize the chances of bugs and inconsistencies arising due to differences in environments. Today, many organizations are working hard to evolve and improve innovation in their information systems quickly and efficiently. As IT consultants, we are often faced with the following scenarios, which can sometimes be frustrating. The development environment that differs from a test QA or acceptance environment in terms of reliability and scaling. The database drivers used in the development and QA environments are not the same as those used in the production environment. The environments have different security rules, firewalls, and configuration settings. These real examples of problems we frequently encounter in the business world can be terrifying, and they can sometimes make build and run teams less confident during deployments and releases. The goal of applying consistency and discipline to dev and prod parity is to give your team and the rest of your organization confidence that the software will work everywhere. This means in all approved targeted environments. The whole host of things can cause mismatches between environments, but the three most common factors that can have a negative impact are typically time, people, and resources. Today's developers have a virtually limitless toolbox. There are very few valid excuses left for not using the same resource types in all environments. Developers can be given their own database instances, particularly straightforward if the database is a service on a PaaS instance. If that is not an option, container tools like Docker can help make production-like environments more accessible to developer workstations. If your development, test, and production environments differ even in the ways you might think don't matter, you lose the ability to reliably predict how your code change will behave in production. This trust in the source code from development to production is critical for the kind of CI/CD that allows 12-factor applications and their teams to thrive in the cloud. Treat logs as event streams. Applications should produce logs in a structured format or treat them as event streams that can be collected and analyzed. Application logs, also known as event logs, are a set of data collected during the execution of an application. They are the only reliable data source for monitoring and supervising the application. They are also used for analysis and troubleshooting in a production incident or any environment issue. In the past, the application was often responsible for collecting the logs, filtering them by level like error, warn, info, debug, contextualizing them, and saving them in files. This method makes it difficult and time consuming to use the logs for operational or monitoring purposes. This is why 12-factor applications favor a more dynamic approach in which the logs are considered a stream of events that describe the application's behavior without having to store the output stream. This way, the routing and processing of logs can be done separately, allowing multiple consumers of logging events for different purposes. Run admin or management task as one of processes. Administrative tasks such as database migrations or data seeding should be run separately from the main application. According to the admin process principle, scripts or processes such as data migration scripts or data populating jobs must comply with the following rules. Scripts should share the same deployment and execution path as the base application and must not be separated from the development lifecycle. This means associating the same build, release, and run sequence for the same code base. The administration process must be executed separately, and isolated from the other production process to avoid any risk of interfacing with the production process in the event of a problem that is a failure or potential performance impact. Starting new execution instance is preferable. Complete parity between the development, test, and production environments means you can confirm that these scripts are working correctly before deploying them in production. Architecture is always evolving, and if there are certain elements of these principles you are not able to meet in the initial phases, don't worry about it. You can make incremental progress and keep measuring the effectiveness of the architecture on a regular basis. For simplicity, these principles can be categorized into three specific areas: development and configuration, runtime, and management and visibility principles. By following these 12 factors, developers can build applications that are easier to develop, deploy, and scale, resulting in more robust and maintainable software systems. You can keep making progress towards your journey on learning these principles and mastering them out as you make more implementations. Only real world examples can make you perfect. Share your journey of building 12 factor apps and cloud native applications to share the experience and knowledge with everyone. Thank you for watching my video.